Presentation is airless tire designed for low gravity surface mobility and sprint tires. Bit of a mouthful. So I was stationed in Cleveland, Ohio, with NASA Glenn Research Center under the Tribology and Mechanical Components branch. Once again, a mouthful. More specifically, I was on the Human Robotic Systems project within the Structures and Materials division. So right now, NASA has several different robotic systems, 3 of which are the rover systems that they sent to Mars. We started with Sojourner, then we continue with Spirit, Opportunity, and the most recent one, Curiosity. Down in the right corner, we have a picture of each of their wheels, and all of these wheels are solid aluminum. Their current system is the Human Robotic System, which is also Robonaut. It's a highly dexterous anthropomorphic robot, and they're wanting to use a different wheel system. Instead of using a solid wheel, they're wanting to use more flexible wheels. This is being spearheaded by Johnson, and Glenn is helping with the research on soil-to-tire interaction and low-gravity situations. Alright, so the objective of the project was to investigate new designs for space-compatible tires, improve the maximum loading of their current tire designs, create our own tire designs and compare them to the current designs, and if possible, build a full-scale prototype and send it to Johnson for further testing. So what exactly is a spring tire? That is the entire point of the project, and a spring tire is a non-pneumatic tire that's made primarily of springs. The current design uses 500 springs that are interwoven by hand. They are very similar to the lunar tires that were used during the Apollo missions. And right now they're kind of the product of the collaboration between NASA and Goodyear. So on a mission, why would you want to use a spring tire? Well, if you have a rover that's on another planet and the tires go flat, your mission just failed. Rubber tires will not work very well in space, primarily because of material reasons. Spring tires themselves do not go flat. They have no compressed air, and they're less affected by temperature swings in space. They're also lighter than rubber and compressed air, and because they're being made out of springs, they actually have built-in shock absorbers. Next slide, please. So the best way to understand the spring tire is actually to build one. So we actually, in this project, built one of the current designs. That was very, very tedious. The next step was to create our own designs. We spent quite a bit of time deliberating about which designs to use, and we came up with 4 different designs. These designs we had as 12-inch scale models for the actual 26-inch tires. We wanted to build small scale so that we could get rapid prototypes and test how they would perform. The hub, which I have there, is a 3D printed part that we made from SolidWorks, and the 3D printer was a MakerBot 2XL. Next slide, please. So concept 1 is a top loader. A top loader is a tire that redistributes the load to the top spokes, which would be up here. The entire wall was made out of the spring mesh and had steel reinforcement stiffeners. And then each of these spokes was made out of the same springs, but were aligned in such a way that they would mesh between the tire and the hub. Next slide, please. Concept 2 is very similar to concept 1 in it has the same outer wall, but the spoke system is designed so that it's aligned radially, and each of the spokes has a curve. This makes it a top and bottom loader, which hopefully gives it more, hopefully it would give it more strength in the tire itself. So next slide. Concept 3 is a semi-toroidal design. This design has differentially sized steel stiffeners. The outer wall, being a curve, gives the tire a bit more of a spring to it, and it also protects the out of the rim from being damaged. This design does not have a spoke system as of yet. We were waiting until after we finished prototype 1 and 2 for testing. Next slide. Concept 4 was derived after we had a field trip to Goodyear. Each of these little wires is a SMA rod or shape memory alloy. These, whenever they deform, if they have a different temperature applied to them, they'll snap back to their original shape. The tire uses SMA rods and spring mesh. The spring mesh keeps the tire's overall shape, while the SMA rods take all the load and can realign themselves properly. So all this is done in the Simulated Lunar Operations Lab, or SLOPE Lab. So the SLOPE Lab itself has a 60 by 20 foot area for testing different rovers, and it has that entire area is designed to simulate the moon. It can be modified, though, to simulate Mars. Also within the SLOPE Lab is the single wheel tester and the low deflection rig, which is what we use for the project. Next slide. And we actually have the low deflection rig here, and on the left we have a flat surface, and on the right we have a wedge surface. These were giving us different scenarios as to how the tire would perform, whether it's on the flat terrain or whether it's going over a rock or something. So next slide. The tire I'm holding is one of our concept tires. It's a lot smaller than the lunar tire. This was a replica that they made a few years back. The lunar tire and it's kind of hard to see, but on the rover we have some of the spring tires that are currently under use in testing. Next slide. So now the fun part of results. So we were able to design and build 4 different concept designs. The performance of 2 of these designs were tested and on a small scale. However, we had not gone to the large scale. The prototypes are being advocated for further study by the personnel under NASA. A few of the people I was under, my principal investigator was Dr. Philip Abel, Colin Krieger, and Kyle Johnson. Thank you. Are there any questions?
Does the dry terrain you're designing for eliminate the need for a protective membrane to keep out particle accumulation?
Because of the way the tires are designed, it doesn't really require so much of a protective membrane. The current tires they have up there do not use a protective membrane. They're just solid aluminum tires that take all of the heating that they get. We're going to basically be using the same thing here. So to answer your question, it's not going to require a membrane now.
So is the goal behind this to simulate a pneumatic tire on Earth without the pneumatics, basically?
That is one of the applications you could use, but it's mostly to try to get a tire that will not damage over time. It will damage some, but the current problems with the solid tires, and they made this unclassified this past summer, the tires themselves will start wearing down very quickly. So they're trying to find ways to avoid a lot of the wear and tear. Because anytime they go over a rock, they dent the metal a little bit, and by adding springs, you can dent it, and then it just goes back to the way it was. Any other questions?
I noticed all of this was using metal springs. Is there anything like the twill, the polymer type thing?
That was something that they're kind of considering, and that's something that Goodyear's also considering. I can't go into detail on that though. So
I was just curious.
that part's
there was
awesome.
a reason that it was only metal.
Right now it's only metal because of availability. The springs are really easy to get. So otherwise we'd have to basically make
That
it.
makes sense.
Did you look at fatigue on this stuff? How does that play in?
What we ended up having on our tires specifically, the tires were starting to deform anytime we put them under testing. And we actually did several loading and unloading tests as well. Right now, with the small scale, we can't actually give a good analysis to the large scale because of the scaling for the tires, because the tires themselves are about half the size of a normal tire, but the springs themselves are not. The springs would be the same as normal tires, so the fatigue doesn't exactly scale linearly with that. I don't know if that answers your question. Sorry. Any other questions?
Have you considered a honeycomb pattern spoke system similar to the ones in the military are testing?
That was considered, but under time constraints, we couldn't really look into it very much. We only had 10 weeks for this project. So.
I think in the past there'd been some sort of investigation of some sort of foam filled type tire. Is that a possibility?
Yeah, that could probably work. Yeah, it wasn't really in on what I was doing, but that probably worked. Any other questions?
I think it's